Hey kiddos, here's the spiral review video for spiral 14. We're going to start off with factoring and graphing polynomials. For each of these, we're going to take a look at the polynomial itself and try to factor this bad Larry. Here we've got 4 pieces. I'm going to group these. For the first two, I can take out an x squared, and I'm left with an x and a minus 6. For the second two, I can take out a minus 16 because I used my calculator to divide, and I can take out an x minus 6. And when I do that, we end up getting x minus 6 as one of my factors and x squared minus 16 as the other factor. X minus 6 is going to give us x minus 6 is equal to 0, which means x equals 6. That's one of my zeros. X squared minus 16 is going to be equal to 0, and that's going to give us x squared is equal to 16. When I take the square root of both sides, that's going to give us x is equal to 4, and x is equal to negative 4. All right, the last piece of kind of the pre-information is identifying the Y-intercept. The Y-intercept is 96. When we're going to sketch a graph of this, we're going to have values at negative 4, positive 4, positive 6, and positive 96. This is a positive leading coefficient graph, which means that we're going to go up at the end, pass through our other points nice and smooth, and go down on the left. For the end behavior, as x goes to negative infinity, that means left, and we just said that we're going down on the left side. We're going to also go to negative infinity for the y. For the right side, as x goes to infinity, that's a right side end behavior. Our graph is going up, so we're going to positive infinity. For the, I guess these are not numbered, but that's okay. For the next problem on this page, we've got to write a polynomial equation in factored form. First thing we do is kind of write a general thing, which is going to have an a in front, and then I'm going to put a bunch of parentheses. I don't know how many I'm going to need, but I've got 1, 2, 3 places I hit the x-axis, so that's probably going to have 3. I don't know why I put an x there, but I'll put an x in each of these. For the first one, negative 2, I'm going to write x plus 2. This is also a bounce because I'm bouncing off the x-axis. And when I bounce, that means that's going to be squared. For the second one, we got x equals 1, so I'm going to do a minus 1, always the opposite sign. This is also a bounce because I'm bouncing off the x-axis, and that means that's going to be squared as well. And then for my last one at 4, this one's not a bounce, I'm passing straight through. We get x minus 4. You've done most of the work at this point. The last thing you need to do is to use the y-intercept. And we're going to say 48 is equal to a. We're going to plug in 0 for all of our x's. So that's going to be 2 squared, negative 1 squared, and negative 4. That's going to be a times 4 times 1 times negative 4. That's going to be a times negative 16. And if 48 is equal to a times negative 16, if I divide by negative 16, I get a is equal to 3. That means my final equation is going to be, it's going to be negative 3. Negative 3, x plus 2 squared, x minus 1 squared, and x minus 4. Moving on to polynomial division. Here we've got to do both long division and synthetic. You've got to do the long division first and then the synthetic to check it. If you choose not to do the long division, you will not be able to get full credit for this problem, although I will make the synthetic division worth more for you. So we got 2x to the third minus 3x squared plus 11x minus 16 and x minus 2 out front. I'm going to see what I multiply x by to get to 2x cubed, and that's going to be 2x squared. When I multiply that down, we get 2x cubed minus 4x squared. When I subtract, I get 0, and I get 1x squared. I'm then going to multiply to get from x to 1x squared, which is plus x. When I multiply that down, we end up getting x squared minus 2x. I'd forgotten to bring the plus 11x down, so I paused because something looked funny. And then when I subtract, we get 0 and 13x, bringing the minus 16 down. I'm going to do the same thing. To get from x to 13x is going to be plus 13. I'm going to distribute. That's going to be 13x, and then minus 26. When I subtract, I get 0 and a plus 10. My remainder is 10. So at the end of this, I'm going to write plus 10 over x minus 2. To use synthetic division to check this, so we're dividing by x minus 2, and you know I like to put that up top just so I remember what I'm dividing by. Put the opposite in the box. Then we've got 2, negative 3, 11, and negative 16. That's going to get us 2. 2 times 2 is 4. I'm going to add to get 1. 2 times 1 is 2. Add to get 13. 2 times 13 is going to be 26. And I add to get 10. You might notice we have the same remainder. That's how we really know that this worked. If you only did synthetic division, you also need to show that this is going to be 10 over x minus 2. We've got a plus 13 for our number. We've got a plus 1x. Then we've got a plus 2x squared. For the last part, is x minus 2 a factor? When we divided, we did not get a remainder of 0. We got a remainder of 10, so that's enough to say that that's not a factor. Is x equal to a 0? What that really means is that, I don't know what letter this is, I think it's a p. So p of 2, in other words, when you plug p in, you should get 0. And you don't. In fact, when you plug when you plug 2 in, you get 10. The remainder is always the number you're going to get when you plug in a value for x. That's equal to what you're dividing by. Next up, we've got the rational root theorem. Here you've got to identify some possible rational roots and then do some dividing in order to factor. I'm going to talk about a couple different ways that you might do the factoring part, but let's start by identifying good guesses. For these, we could do some fractional ones. In this one, we don't need to because the beginning is a 1. But we're just going to identify factors of 10. And when we do that, that's going to be 1 and negative 1, 2 and negative 2, 3 doesn't work, 4 doesn't work, 5 and negative 5, 6 doesn't work, 7 doesn't work, 8 doesn't work, 9 doesn't work, and then we got 10 and negative 10. If it helps you, you could also write these as factors, although you certainly don't have to. That'd be x minus 1 and x plus 1. That'd be x minus 2 and x plus 2. That'd be x minus 5 and x plus 5. And that would be x minus 10 and x plus 10. I'm okay with you writing these in either format, as factors or as roots, or if you'd like to write both, that's okay too. I recommend that you write them separately for the pluses and minuses just because it makes it a little bit easier. I don't really know where to begin with this, so I might try to begin with a smallish number. Maybe I'll try with x minus 1 because that's the first thing I see here. That means that plus 1 is going to go outside, And inside we're going to have 1, negative 6, 3, and 10. I'm going to bring down my 1. And when I do that, we multiply to get 1, we add to get negative 5. We multiply to get negative 5, we add to get negative 2, we multiply to get negative 2, and we add to get 8. 1 does not work. I did not get 0 at the end. That means that that is not possibly a factor for us. The next one I might try, I don't know, maybe x minus 2, which means I'm going to put a 2 out front. 1, negative 6, 3, and 10. 1 comes down. 2, negative 4, negative 8, negative 5, negative 10, and 0. So second try, that's not bad. In fact, that's pretty good for these things. And I could handle this a couple different ways. What I think is the easiest approach based on the stuff that we've done this year is to factor this. This would be 1x squared minus 4x minus 5. And I know some of you disagree about the easiness of factoring, but that's okay. So we've got a times c is negative 5, b is negative 4. That's going to be negative 5 and positive 1. So we'd have x minus 5 and x plus 1. Okay, looking at what we've got inside of our parentheses, the first one I'm going to put is going to be x minus 2. That's why I divided by. The next one I'm going to put is going to be x minus 5. And the last one is going to be x plus 1. If you hate to factoring, there's an alternative way to do this. And that's taking the values that we have here and starting dividing using those. So 1, negative 4, and negative 5. Based on our new last number is negative 5, the only numbers to try would be 1 and 5. We already tried x minus 1, that didn't work. So let's try x plus 1, which is minus 1 here. 1, negative 1, negative 5, positive 5, and 0. That gets us that same x plus 1 and that same x minus 5 without actually having to factor. If you prefer doing synthetic division, and I know that some of you do, that would be a way to avoid factoring. The last part, identify all zeros. Once you have the factors, these would be the numbers that make each of those parentheses equal to 0. So x equals 2, x equals 5, and x equals negative 1. And finally, we got the new stuff. Here we've got rational functions. The first part, we're describing the behavior of rational functions, and for the second part, we're going to be sketching a graph. First off, we've got some end behavior pieces. This is as x approaches negative infinity, that means we're going to the left. So I'm going to look at my graph going to the left. It looks like we're approaching a height of 1 on our graph. So I'm going to say y approaches 1. And for the next one, going to the right, on our graph on the right side, we're approaching, it looks like the same value. We can't see a lot of this graph because I wanted us to see the behavior at the middle pretty well. But this would be approaching 1 as well. That's a horizontal asymptote. And if you have a horizontal asymptote that's equal to 1, both of these end behavior values are going to end up being 1 as well. That means we're approaching 1 on both sides. The other part of this is about the asymptote. As x approaches negative 2, oh, that's totally supposed to be positive 2. That's fun. From the right. So now we're talking about this side. That little plus means from the right. And as we approach this from the right side, it looks like our graph is going down. And down would be negative infinity. Same thing for the other part. From the left side, this minus means from the left. our graph is going up, so we're looking at a positive infinity. I also just want to mention on the next version of this problem, here, this is an oblique asymptote. It doesn't approach a value on both sides. It keeps going up and keeps going down. So on the left, we're going down. That means that that would be negative infinity. And on the right, we're going up. That would be positive infinity. The other part's really similar to what we did before, so I'm not going to go through that. Let's talk about graphing. There are no numbers in this spiral. This is super fun. X plus 2 over x minus 3. For the vertical asymptote, that's going to be whatever makes the bottom equal to 0. So x minus 3 is equal to 0. That means that x is equal to 3. So I'm going to have 3 on my graph and a nice vertical dashed line to show that off. For the horizontal asymptote, I'm going to use the ratio of my leading coefficients because we're talking about when x gets wicked big, which means the other pieces don't matter. And if I've got 1x over 1x, that's equal to 1. Y equals 1 would be my horizontal asymptote. So I might do a nice horizontal dashed line, identify that as a height of 1. For the x-intercept, we said that's when y is equal to 0, but the shortcut is just looking at the top of this. If x plus 2 is equal to 0, x equals negative 2 is my y-intercept. And I like how I was talking about x-intercepts, but just said y-intercept, sorry. And then finally, we're looking at the y-intercept this time. I'm really talking about that. That's when x is equal to 0. So I'm going to plug that in. We get 0 plus 2 over 0 minus 3. And that's going to be y is equal to negative 2 over 3. And again, all you need to do is to identify that point. And I'm not going to give you a grid, so you don't really need to worry about getting that exactly right. The last piece is to draw a nice smooth curve. I know I've got to connect these 2 points. And my graph's got to look something like this. Some of us call this a weird C or a funky L. Either of those are okay. And we're going to have the other half in the opposite corner. So something like this. I am also going to graph the second one of these because I'd like us to talk about the transformation here. Here we've got a mother function that's centered at 0, 0. This would mean that we're going right 3 and up 2. And what I'd like us to also think about that is that the horizontal asymptotes and vertical asymptotes are moving as well. So for the vertical asymptote, it's going to start at 0, go right 3, or you think about what would cause us to divide by 0, and that's going to be x equals 3. The horizontal asymptote is going to be based on moving up 2 from 0. That gives us a y is equal to 2. These forms of equations are really easy to find the asymptotes for, but a little bit harder to find the x and y intercepts for. In fact, finding the x-intercepts, some of you might call a force. So let's do the y-intercept first. We know that's going to be based on when I plug x equals 0 in. So 1 over 0 minus 3 plus 2 is going to be about 1.7. So y-intercept of 1.7-ish is going to be here. For the x-intercept, we're going to start out with 0 is equal to 1 over x minus 3 plus 2. Negative 2 is equal to 1 over x minus 3. I'm going to continue this work over here. I'm going to multiply both sides by x minus 3, and I get negative 2 times x minus 3 is equal to 1, which means we've got negative 2x plus 6 is equal to 1. Negative 2x is equal to negative 5, and x is equal to positive 2.5. With the same type of thing we had in the last one where we have 2 points on one side, and the opposite corner would have the other side of that graph.